Good morning. This is your Stat Sensei, Mr. Spensei, and this is Death Packet, Unit 4P, Proportions. So, which of the following is a true statement? The sampling distribution of P hat has a mean equal to the population proportion. And basically, that's saying that is not, there we go, that P hat is equal to P. And yes, the mean is equal to the mean of the mean is equal to the mean. So, like that answer, and that happens to be our answer for this one, but I want to talk about the other as well. The sampling distribution of p hat has a standard deviation equal to np times the square root of np times 1 minus p. Well, um, oops, I hit the wrong button here. And the problem with that is for the binomial. Please remember that p hat, the standard deviation of p hat equals the square root of p hat times 1 minus p hat, all divided by n. So that's why that's wrong. So B is wrong. C, the sampling distribution of p hat is a standard deviation which becomes larger as the sample size becomes larger. Well, if I'm increasing n, my standard deviation actually goes down. So as n goes up, standard deviation goes down. So that's false. The sampling of distribution of p hat is considered close to the normal, provided that n is greater than 30. That is true for population means. We're talking about proportions. Um, it becomes close enough where we get to use the normal approximation if np hat is greater than 10 and n times 1 minus p hat is greater than 10. If both of those are greater than 10, then it's normal enough. So that one is wrong. That applies to means. The sampling distribution of p hat is always close to the normal. No, it's close enough when we satisfy these two conditions. So that's wrong. Answer choice is A. All right. Number two, a confidence interval estimate is determined from the GPAs of a simple random sample of n students. All other things being equal, which of the following will result in a smaller margin of error? All right, let's talk about margin of error. As sample size goes up, margin of error goes down. As confidence level goes up, margin of error goes up. And here's why. um, if we just take any, doesn't matter what we're using for, whether it's means or proportions, and I'm going to look at means just because it's easier to understand. T star S divided by the square root of n. T star is governed by the confidence level. As that gets bigger, T star gets bigger, we're multiplying. So the margin of error goes up because this is our margin of error right here, this part. If n goes up, we're dividing by n. And if we're dividing by n, as n goes up, the margin of error goes down because you're dividing. And then, of course, if our standard deviation, oops, if our standard deviation goes up, then the margin of error goes up as well. So which of the following will result in a smaller margin of error? A smaller confidence level. I like that answer. Let's see if there's any others that are better. A larger sample standard deviation. No. As that went up, margin of error went up. So that's false. A smaller sample size. As sample size goes up, margin of error goes down. So if we went the other way, sample size go down, the margin of error goes up. So that's false. A larger population size has no bearing on the margin of error. A smaller sample mean. The mean is not included, although the mean is in the confidence level formula, it's not part of the margin of error, so it also has no impact. All right, so our best answer choice for number two is A. Number three, a recent study reported that 15% of flights, or 1.5, excuse me, 1.5% of flights are canceled by by air carriers. Consider a simulation with 50 trials. All right, so we're going to repeat this thing 50 times, designed to estimate the number of canceled flights from a random sample of size 100. All right, where the probability of success a canceled flight is 0.015. Which of the following dot plots best represents uh, from the simulation described? Well, all right. So if we have a 1.5% chance, we go, all right, 0.015 times 100. Well, we'd expect 1.5. So on average, we expect it to be 1.5. So we should be centered on 1.5. So I can look around here and go, well, which one of these is centered on 1.5? This one looks to be the most centered on 1.5. And if we did it 50 times 50, we'd expect it to happen about 75 times. Or excuse me, we'd expect to have 75. So if we added up these values right here, um, we would expect, I'm saying that completely wrong. But the one that's the main thing you need to look for is look for it, see where it's centered. It's centered on 1.5. And once again, that 1.5 was 0.015 times the 100. All right. Times the 100 equals 1.5. That's where we need to be centered. This is the one that's centered on that. All right. Next one. I did not do a good job with that. I apologize. Number 4. An advertisement reports that the proportion of consumers who respond favorably to a certain advertisement is 0.07. 3 simulations, A, B, and C, were designed to create a sampling distribution of a sample proportion from a population with a proportion with proportion 0.070, so P equals 0.70. And our P hat's going to be the same. Each simulation consisted of 2,500 trials. For each trial of a simulation, a sample of size N was collected. All right, so we have different size samples. We're going to do it 2,500 times, but we have different size samples. And the sample proportion was recorded. The value of N varied among the simulations. That's what we just said. It's changed. The following histogram summarizes results of the simulations. Which of the following lists the simulations in order from least sample size, all right, to greatest sample size? So we're going from least to greatest. Well, oops. I know this, that as N increases, as my sample size increases, my standard deviation or my variation is going to decrease. All right. So the one that has um, the most spread out, is actually, I'm going to scratch that out. That's going to be confusing. The most spread out is the one with the greatest N. So first off, I mean, I said that backwards, completely backwards. The least spread out has the biggest N. So let's look at this. This looks like this goes from, and I'm just going to look at the range because it makes it easy. This is like 0.45 here, and this looks like this is 0.95 there. So 0.95 minus 0.45 equals 0.5. All right. When I look at this one looks like it goes from, oh, I don't know, 0.67. You know what? We're just making 0.68 just because I make it easy. And this is 0.72. So 0.72 minus 0.68 gives me a range of 0.04. And then this one, when I'm looking at this one, we're going from 0.6 to, let's just call it 0.85. 0.80, it will work better. So 0.6 So here we go, 0.80 minus 0.60 equals 0.2. All right, well, this one is spread out the most. Most spread, smallest n. This one is the least spread out, the least amount of variation. Least spread, biggest n. And this one right here, middle. So it's going to have the middle n. So it looks like if we're going from least to greatest, A was the least, smallest n. C had so this is the smallest n, this is the largest n, and B would have been in the center. So what we looks like we're looking for is a I did that in a complete order wrong. This one was the least, so this is B, this is C. C ended up in the center. So it looks like we're looking for ACB, and ACB happens to be letter B on that one. All right, number 4. An online news source reports that the proportion of smartphone owners who use a certain operating system is 0.216. 2 simulations will be conducted to create a sampling distribution of the sample proportion from a population with proportion 0.216. Simulation will consist of 1,000 trials with a sample size of 50. Simulation B will consist of 500 trials with a sample size of 100. Which of the following describes the centers and variability that should be apparent in the distributions generated by sampling distribution A and sampling distribution B? I'm going to need to pause this for just a moment. All right, welcome back. So, which of the following describes the centers and variabilities that should be apparent in the 2 distributions? So we have 2 distributions, and we have a population proportion equal to 0.216. Well, they're going to run 2 different types of simulations, one with a sample size of 100, one with a sample size of 50. They're running 1,000 trials with the one with 50 and 500 trials with 100. So let's go ahead and put these together. Those go together, and the 1,000 trials with a sample size of 50 go together. All right, so first off, the mean is the mean is the mean. So it doesn't matter which sample size you had, even if you had a sample size of 1, the centers should be approximately equal. All right. So if that's the case, that gets rid of D and E because the mean is the mean is the mean. So P hat 1 and P hat 2 from the same population should be approximately the same. Matter of fact, there will be variation, but we don't know which way it's going to go. All right. Now, they mess you up by including the trial sizes. The trial sizes will just tell you how many values we end up with on each one. We don't really care about the trial sizes. What we care about the sample size. And simulation B has a sample size of 100, and simulation A is a sample size of 50. Well, as n goes up, standard deviation of p hat goes down. So our variation decreases as our sample size increases. So the centers will be approximately equal and the variability will be roughly equal. No, B is going to have smaller variability. The centers will be approximately equal and the variability of A will be greater than B. Yes, B has to be less. We like this one. Let's read this one. The centers will be equal and the variability simulation A will be less. No, that's false. B is going to be less. Our best answer choice to number 5 is B. All right, moving on to number 6. A survey was conducted to determine the percentage of high school students who plan to go to college. The results were stated as 82% with a margin of error plus or minus 5%. What is meant by plus or minus 5%? Well, first off, if they're saying 82 plus or minus 5, well, 0.82 plus or minus 0.05. That means it could be 77 to, because 82 minus 5 is 77. 82 minus 0.05 is 77, and 82 plus 0.05 is 87. All right. So the margin of error says how far we are. We gives us where we think it's going to lie. So given our center point, and our center point is 82, we don't think it's going to be lower than 77 or higher than 87. So when we're looking at this one, 5% of the population were not surveyed. No, that's not. That's just telling you how much variation we expect it to be. No higher, no lower. In the sample, the percentage of students who plan to go to college was between 77 and 87. No, we know in the sample the percentage of students who plan to go to college. That's true, but that has nothing to do with the margin of error. The percentage who plans to go to college was 82%. It was actually the center, so no, that's not right. The percentage of the entire population of students who plan to go to college is between this. This is not stated right. The percentage of high school students of the entire high school students, we believe the true population proportion is here. So this is not likely. This is not it. It's unlikely that the given sample proportion result would be obtained unless the true population was between 77 and 87. And that's what we're saying. In repeated sampling, we expect to capture it. I mean, if we did this over and over again, we expect it to be here, somewhere in between here. That's what we believe. All right. 1 month, the actual unemployment rate in France was 13.4%. If during that month you took a simple random sample of 100 Frenchmen and constructed a confidence interval of the unemployment rate, which of the following would be true? Well, so in this case, P equals 0.134, and we'd expect P hat to be the case, but it doesn't mean that it will be. So if you take an interval and I take an interval, there's going to be variation. Because of variation, that may not happen. The interval contained 13.5. We don't know how wide this interval was. We don't have any data like that. 99% confidence interval estimate contained 13.4. Well, 1% of them wouldn't, so I don't really like that one. We're not saying it's the worst. The Z-score 13.4 was between plus or minus 2.56. That's not a Z-score. That's actually the population proportion. So our best answer choice is E. None of these were better. Were the best. Remember, 99% confidence interval contained it. Might have, but you still may have had that 1% where it didn't. So we're not guaranteed that it would have contained it. Number 8. In a certain region of the country, the proportion of population with blue eyes is currently 17%. All right. So P equals 0.17. A random sample of 100 people will be selected from the population. What's the sampling distribution of the sample proportion of people with blue eyes of sample size 100? They asked for what was the mean. All right. Of the sampling distribution of the sample proportion of size 100. So in this case, the mean is the mean is the mean. Our mean is 0.17. All right, because we're talking about the center of the sample proportions. All right, in other words, if we were drawing the normal curve, we'd expect it to be centered on 0.17 because that's where P is. All right, so next one, number 9. Maybe they're sticking together a little bit. At a national convention attended by many educators, about 30% of the attendees are from the Northeast. All right. Of all the attendees of the national convention, 25 will be selected at random to receive a free book. What are the mean and standard deviation of the sampling distribution of the proportions of attendees of sample size 25? All right. So first off, P equals P hat, or P hat equals P. So we'd expect it to be 0.30 because the mean is the mean is the mean. Right there, that tells me I should be looking at that. And sure enough, the formula for the standard deviation is P times 1 minus P over N. So P equals P hat, and all we have to do is plug in that, and we'll get 0.3, 0.7, and the sample size of 25. Excuse me. A manufacturer of computer monitors estimates that 4% of all monitors manufactured have a screen defect. That PD represent the population proportion of monitors manufactured that have a screen defect. All right. For the sampling distribution of the sample proportion for samples of size 100, mu of P hat D equals 0.04. Which of the following is the best interpretation of mu of P hat D? All right, so for all samples of size 100, the mean of all possible sample proportions manufactured have a screen defect is 0.04. No. For the average of all samples, yes. But in this case, we can't say all samples will have that. Some samples will be greater, some samples will be less. For all samples of size 100, the standard deviation of all possible proportions have a defect is 0.04. No, because once again, you're going to have variation from sample to sample. So that makes A and B both wrong. For a randomly selected monitor, the probability that the selected monitor will have a defect is 0.04. Yeah, that's true. Like that one. For each sample size 100, the proportion of monitors, nope. This says basically for all samples. And it's the average of all samples that's true, but not for every single individual sample. So, some samples will be greater, some samples will be less, but it'll average out to this. And finally, for randomly selected screen monitor, the mean number of defects from the monitor will be equal to 4. I'm not even sure how to express that one's just not even close. All right, I appreciate you watching. Sorry for the cold. Talk to you later.